This ball kills 100,000 marine animals yearly. Not directly, of course, it would be strange, but its impact is undeniable.
Here's the twist. Back in 1869, billiard balls were made from ivory, leading to the destruction of countless elephants. But that changed with John Wesley Hyatt's invention of celluloid, the world's first plastic.
While it wasn't a perfect replacement for billiard balls, it revolutionized materials science. Celluloids could mimic natural substances like corn, linen, and even ivory, paving the way for a world of new possibilities
and unexpected consequences. For the past 150 years, we've discovered the amazing world of synthetic polymers, which harness the abundant carbon atoms found in petroleum and other fossil fuels.
These synthetic polymers consist of long chains of atoms, making them strong, lightweight, and wonderfully flexible. This flexibility allows them to be easily shaped into all sorts of useful forms.
So essentially, they're plastic. Hello, my name is Lily, and today we will find out
how many elephants were saved due to the invention of plastic, how ice cream is linked to caring for nature, the role of worms and nanotechnology in nature-saving efforts, how much danger Great Pacific garbage patch holds, and how microplastic can make archaeology useless.
What if plastic had never been invented? Would our world be better? Or have we traded convenience for irreversible consequences? Plastic was initially hailed as a groundbreaking solution, born from noble intentions to save trees, wildlife, and the environment.
Consider this. In the early 19th century, Africa may have been home to as many as 26 million elephants. By 1979, their population had plummeted to around 1.3 million, and by 1989, only about 600,000 remained. The primary cause? Ivory was in high demand for jewelry, piano keys, billiard balls, and more.
The invention of early plastics like celluloid in the late 19th century provided a much-needed alternative to ivory, offering hope for the survival of elephant populations. Yet as plastic production exploded in the 20th century, it became evident that the solution came with its own set of environmental challenges, trading one crisis for another. Since the 1950s, humanity has produced over 9 billion tons of plastic, yet only 9% of it has been recycled. The rest, you'll ask, remain in the environment, polluting the land and the sea. At this rate, by 2050, plastic could outweigh all the fish in the ocean.
Why is this happening? One reason is that making new plastic is usually cheaper and simpler than recycling it. Plus, in many areas, there just aren't enough facilities to manage all the plastic waste we produce. Single-use plastics, such as bags that are typically used for only 12 minutes, along with bottles and packaging, create a never-ending wave of waste that can overload recycling systems.
And if you, just like me, assumed that the recycling crisis was primarily a problem with the material itself, I'm sorry to inform you. It's all about the money. Recycling plastic isn't just a technical challenge, it's a financial one.
Thin plastic films like grocery bags, cling wraps, flexible packaging, and single-use items such as utensils and straws are often excluded from recycling programs.
These items are not only small and low in value, but they also tend to tangle in the recycling machinery, causing jams and disrupting the entire process.
Biodegradable and compostable plastics, marketed as eco-friendly alternatives, pose challenges of their own. While they are designed to break down more easily, they often don't decompose efficiently in traditional recycling systems. Proper disposal of these plastics requires specialized facilities that many recycling centers simply don't have.
But then maybe burn it? But I don't think it's a good solution either. It would lead to an environmental disaster by releasing toxic chemicals and greenhouse gases such as carbon dioxide into the atmosphere.
These substances not only contribute to air pollution and global warming, but also pose serious health risks to humans and animals. Furthermore, the process often produces fine particulate matter that can settle in nearby communities, causing respiratory and cardiovascular problems.
The ash residue from burning plastic can also contaminate soil and water sources, creating a ripple effect of environmental harm. So, maybe don't touch it at all, leave it as it is. But again, no, allowing plastic to decompose naturally is also not an option, as many plastics can take decades or even centuries to break down.
Consider this. If you leave a cardboard box in a forest, its components will typically return to the ecosystem within a year. Plastics, however, break down much more slowly, causing long-term harm to the environment.
But here's where things get tricky. Plastics are often sorted and identified by recycling numbers, also known as Resin Identification Codes. These codes, ranging from 1 to 7, are usually found inside a triangle of arrow and plastic items. They help recycling facilities and consumers identify the type of plastic used, making it easier to manage and recycle.
Let's take a look at the chart. Notice that codes 1 and 2, like water bottles and milk jugs, are wildly recyclable, making them relatively better options. However, even these plastics take 450 to 500 years to decompose. As you move down the chart, you'll see codes 3, 6, and 7. Plastics under these codes are rarely recycled and last up to 1,000 years in the environment. These are among the most problematic plastics. On the recyclability scale, codes 4 and 5 fall in the middle. Items like grocery bags and bottle caps are recyclable in certain facilities but still have a significant environmental footprint.
As we can see, even the easiest to recycle plastics stick around for centuries if not recycled properly. So even with these codes, the reality is recycling plastic efficiently remains a huge challenge. Many facilities struggle with processing mixed or contaminated plastics, meaning that even though we have these systems in place, we still face significant hurdles in managing plastic waste effectively. Luckily, many scientists are actively working to find efficient solutions to the plastic crisis, and nature itself might hold the key.
Take the wax worm, for example. These tiny larvae, known as Galeria melonella, have amazed scientists with their ability to break down polyethylene, a common plastic. While the worms themselves aren't the solution, the enzymes they produce to degrade plastic could be a game changer. Researchers are exploring ways to harness these enzymes in industrial settings to break down plastic waste at scale. If this can be replicated efficiently, it could revolutionize the way we deal with plastic pollution in landfills and oceans.
Another fascinating solution comes from the world of fungi. In 2011, a team of Yale students discovered the remarkable fungus Pestalotiopsis microspora, thriving in the rainforests of Ecuador. This fungus doesn't just consume plastic, it thrives in oxygen-starved environments like landfills where most lives struggle to survive.
This discovery is still in its early stages, but researchers are investigating the potential of fungi to be used in bioremediation projects. If successful, fungi could be used to break down plastic waste in landfills or polluted environments, helping to restore ecosystems over time.
Next solution really excites me. A plastic to vanilla ice cream situation. Scientists at the University of Edinburgh found a way to turn post-consumer plastic into synthetic vanilla flavoring.
Using genetically engineered E. coli bacteria, they convert terephthalic acid, a molecule found in PET plastic, into vanillin, the key compound in vanilla. This innovation could create a way to recycle plastic into a high-value product, turning waste into something delicious. While it's not yet a widespread commercial process, it holds huge potential for transforming how we think about plastic waste, turning it into a resource for the food and flavor industries. Another promising solution in the world of biodegradable plastics is PBAT. Discovered relatively recently in the 1990s, PBAT combines the flexibility of synthetic polymers with biodegradability, making it ideal for products like plastic bags, wraps, and agricultural films. What sets PBAT apart is its ability to break down in composting environments, offering a more eco-friendly alternative to traditional plastics.
However, despite its biodegradable nature on land, PBAT doesn't degrade in marine or freshwater environments. This means it can still pose a significant threat to the marine life if it ends up in our oceans. This brings us to a bigger problem: plastic soup. This is a term used to describe the massive accumulation of plastic debris in our oceans. It's not just a threat to wildlife and the environment, it's becoming a serious issue for humans as well.
There are 5 major spots in the world's oceans where rotating currents form massive, slow-moving whirlpools called gyres. These gyres aren't just important, they're essential for the health of our oceans. They help regulate temperatures, move nutrients around, and keep marine ecosystems thriving. But here's the catch. They also act like giant traps, pulling in debris, including plastics, and collecting it at their centers. Out of all of them, the North Pacific gyre is the largest, and it's earned a pretty bad reputation. It covers a mind-boggling 1.6 million square kilometers, about 6 times the size of the United Kingdom. It's home to the infamous Great Pacific Garbage Patch, a zone with an estimated 1.8 trillion pieces of plastic, weighing roughly 79,000 metric tons.
Oh, but don't picture a giant island of trash floating on the water. The Great Pacific Garbage Patch isn't some massive heap of bottles and bags you can walk on. If you'd visit it, you'd be surprised to find that the visible waste isn't as alarming as it sounds. Some of it can be scooped up and turned into creative solutions like floating islands, like this one. But the real danger? It's the stuff you can't see, the microplastic.
Studies estimate that at least 14 million metric tons of microplastics now rest on the ocean floor, forming a hidden layer of waste that blankets the depths like a silent, toxic shadow. These fragments originate from the breakdown of larger plastics, microbits and personal care products, synthetic fibers from clothing, and microfibers that release during laundry.
One more time, just to make it clear. 80,000 metric tons of plastic can be seen floating on the surface in the most polluted part of the ocean, while 14 million metric tons rest on the ocean floor. These numbers clearly illustrate just how invisible the threat of plastic is and how much greater the invisible danger is compared to the visible one.
They infiltrate every corner of our ecosystem, from the depths of the ocean to the highest mountains, and even the ancient remains that date back to the 1st century AD. Yes, you heard it right. Just a few months ago, a group of researchers from the University of York was studying almost 2,000-year-old soil samples. The samples themselves were excavated more than 7 meters below the ground in 1980.
Scientists found 16 different types of microplastic polymers in these samples. Such microplastics were widely used in some cosmetic products until around 2020. And their particles somehow penetrated ancient soil samples. This is very bad news for archaeology.
Professor John Sheffield from the University of York says that now it's clear that our historical heritage contains toxic elements. And if the presence of microplastic can change the chemistry of soil and cause the decay of organic remains, then preserving it may no longer be appropriate.
The magnitude of the microplastic problem is mind-blowing. Studies have found microplastics in the air we breathe, the water we drink, and even the food we eat.
They enter the food chain at the lowest levels, consumed by plankton and other small organisms, eventually making their way up to the larger marine animals and ultimately to us.
Luckily, scientists are working on the solutions to this problem as well. One remarkable discovery involves the development of robotic fish designed to remove microplastic from water.
These fish, equipped with specialized surfaces that mimic the texture of fish scales, have strong chemical bonds and electrostatic interactions with microplastics, allowing them to effectively attract and capture these tiny particles. While the current prototypes operate primarily on water surfaces, ongoing research aims to enhance their functionality, enabling them to explore deeper waters where plastic pollution remains prevalent.
Nanotechnology also offers promising solutions for capturing and removing microplastics from water systems. Scientists are developing advanced filtration systems with nanoscale pores that can selectively trap microplastic while allowing water molecules to pass through. In addition to removing existing microplastics from the environment, efforts are underway to develop biodegradable alternatives to the conventional plastics.
Researchers are exploring the use of biopolymers derived from renewable sources such as plant starches, cellulose, and chitin to create environmentally friendly plastic substitutes. These biodegradable alternatives offer a sustainable solution for various applications, including cosmetics, personal care products, and industrial processes where plastics are commonly used.
Plastic has shaped the modern world. Its convenience has revolutionized industries, from food packaging to healthcare, transportation to electronics. While initially seen as a solution to save trees by replacing paper, it's ironic that instead of saving, we're losing. However, we can't simply abandon this remarkable material. Rather, we must be more mindful of its use and the resulting consequences.
Globally, we produce over 300 million tons of plastic annually, and nearly half of it is used just once. Making small changes in how we reduce, reuse, recycle, or repair plastic can help extend its lifespan beyond those fleeting 12 minutes of use.
And let's hold on to hope that scientists, waxworm, and fungus would clean our mess as they always do. Thank you for your time. See you in the next video.